let's look at a different situation. This time our container doesn't have flexible walls. It is a rigid container. So if we heat it, we heat our gas in a rigid container, how does the pressure change? The pressure will go up. And if we want to say how much the pressure goes up, we're going to use this equation. Where we have a pressure 1 before we heat it and a temperature 1. And then over here we know what we're heating it to, but we're looking for P2. Okay, again, in this situation, the volume is constant, and again, it's a closed container, so the number of moles are constant. Let's look at how this works. Okay, this time I have it in a rigid container that will not get bigger as I heat it. And so we're going to see what happens to the pressure as I heat it. Now remember, pressure means like pushing against the container wall. And so if you're interested in looking at pressure, choose a side of the container and look at how often it's being hit by the particles, by the gas particles. Okay, let's heat it up and see what happens. And you can watch the pressure gauge as well going up. Okay, the pressure has gone up quite a bit. Luckily our container must be pretty strong because it didn't bust. And then you can look at the collisions along the container wall. Notice that the particles are hitting more often, and that's one reason the pressure is higher. More pushing, they're getting hit more often. But the walls of the container are also being hit harder. These particles are moving a lot faster since temperature reflects the kinetic energy. They're moving faster. And so when they hit faster, they're hitting harder with more force. So that's part of why the pressure goes up. Let's go ahead and continue heating it and see if we can heat it enough that the container can't take it anymore. The pressure gets too high. Strong container. Oh, there it goes. Notice the pressure goes down right away when we have fewer particles.